Okay, so in this sample, I'm just trying to show you what happens when you do multiple wires. So this is 15 wires. They're 0.4 millimeters. It's a good idea that they are lovely and new, but so what I'm doing right now is I'm just separating them so that they're coming out of my bundle, which is in my vise or my clamp, and they're nice and even. I'm going to do sets of 3 because 15 divides by 3 nicely, so I should have 5 sets. I know I can do a braid with 5, so I am just separating them so that they come out of here in a nice even start point. Otherwise what happens is I just waste more wire. Obviously a little bit confusing. That is one of the problems with doing so many wires. The other problem is, so now I've got my groups. I'm going to treat these just like they are one wire, except for I have to make sure they all stay parallel. See how this one here is all overlapping? I need them to start parallel and I need them to braid parallel. I don't want them to twist as I go, because it's going to just make my braid look like a rat's nest, and we don't want a rat's nest. So I've got 3 wires here, 2 wires here. And when I say wires, I actually mean groups of wires. Okay? So I'm going to take the outside wire or group, hold the middle 2 wires, cross them, slide them up. You can see how all 3 of them are side by side. Then this becomes part of my middle. This becomes my outside wires now, holding the middles, crisscross them, pull it into the middle. And I got these outside 3, and this is where it gets confusing. I got to make sure that every time I grab the proper 3, and make sure that they're not crossed over, so I can actually do this. Grab one at a time if I need to. Now I know that they're not crossed over. Now I'm going to pull them tight and bring them in parallel. Now I'm going to get my outside 3 again. Eventually, they will start to stay in little groups because they are grouping together at the back there. So what makes this more difficult is that it has more, it's just more wires means more confusion, more chances of this overlapping improperly as I do what I just did, which is the crossover and slide. But also, I don't know about you guys, but it's really hard to solder 0.4 wire normally. Now all of a sudden, I've got 15 0.4 wires when I do my closed sample that all need to be soldered together. All perfectly, with strong, beautiful joints that you can't see. It is virtually impossible. The other thing you can do is one of the samples that I'm bringing to class has a silver cab set on the middle, and essentially I can just hide the joint underneath the cabochon, which solves my I can't get a perfect joint problem. I don't know if there's such thing as a perfect joint when it comes to this, but there are ways around it of disguising our inability to get perfection. Because if you can't see the joint, nobody will know if it's perfect or not. Doesn't need to be perfect. It is confusing. It does, however, give you a lovely effect. So this is very similar to the double. It's just beefier. If I added more wire, it would just make it wider, and so on and so forth. If the wire is thicker, it makes it thicker this way as well as wider. If I was going to roll it out, I need to have thicker wire because of that overlap problem. Remember we were talking about this during twisted wire, is when a wire overlaps itself At that point right there, when they compress into each other, they will be half as thick as their original thickness. So that has to be taken into account. Plus, when you did your twisted wire, those of you who twisted it, rolled it out, and then tried to bend it, it wants to break in those areas. So you've got all these strategical weak spots that you want to avoid. Okay, so that's just a more complicated. And remember, you'd have to solder all 15 of these wires when we made our closed sample to fit our ring. So if you're not really good at soldering, you probably want to avoid this little guy. Okay?